This is the Usibelli coal mine at Healy in interior Alaska. Today, the Usibelli mine is a model of modern mining technology. A far cry from the days when pioneer Alaska developer Austin E. Cap Lathrop first began mining here over 60 years ago. In 1918, construction on the Alaska Railroad reached Healy 250 miles north of a tiny port community called Anchorage, 100 miles south of the bustling gold center of Fairbanks. For 4 years, horse-drawn sleds hauled the first coal 4.5 miles from Suntrana to the railroad. Then in 1922, a spur was completed, linking Cap Lathrop's Healy River Coal Corporation to the main line. In those days, the mine's only customers were in and around Fairbanks. In 1943, an Italian immigrant named Emil Usibelli opened his own strip mine at Suntrana near Healy. He had 1 tractor and 2 trucks. Others laughed and took bets on how soon this chichaco would fold. But there was a war on, and Usibelli convinced military officials at Ladd Field near Fairbanks to give him the contract to supply their power plant. Emil Usibelli was off and running. In 1950, Cap Lathrop was killed in a mining accident, and his mining operations were sold to Suntrana Mining Company. 11 years later, Usibelli bought Suntrana out. In 1964, a mining accident claimed the life of 71-year-old Emil Usibelli. Suddenly, his 25-year-old son Joe, a graduate student at Stanford, was in charge of a multi-million-dollar operation with annual sales of just under 400,000 tons of coal. Joe Usibelli quickly proved himself capable. Over the next 2 decades, in-state sales more than doubled to 800,000 tons per year. By this time, Usibelli's customers included the Fairbanks Municipal Utilities Plant on the banks of the Chena River, the University of Alaska plant at College, a large plant at Eielson Air Force Base, 26 miles southeast of Fairbanks, Clear Air Force Base near Healy, the old Ladd Field plant renamed Fort Wainwright, and Golden Valley Electric Association, serving the outlying areas around Fairbanks. And today, a small but unique customer is Reliable Coal in Healy, providing retail coal sales to residents and small businesses in interior Alaska. And in 1984, Usibelli Coal became the first significant exporter of an Alaskan mineral resource with the signing of a 15-year contract with the Sun Eel Alaska Corporation to supply over 800,000 tons per year to a power plant in Honam, South Korea. But at 1.6 million tons per year, Joe Usibelli feels there's still room for growth.
We think that our optimum efficiency at this point with the current fleet of equipment and the way we're structured now is probably somewhere between 2 and 2.5 million tons a year.
Over the past 2 decades, Usibelli has built a state-of-the-art operation using the latest equipment and backing it up with a computerized, automated parts inventory system.
The mechanic will come to the warehouse, ask for the warehouseman for a specific part. The warehouseman will look it up in the parts book, locate it on the computer. Computer tells where it is located. When it's checked out, everything in the history of that part is updated. The number of parts on hand is subtracted. The cost of that part plus a stocking charge is charged to the operating cost of that piece of equipment. Most of the smaller parts are located in the mini tree, what we call the mini tree, which is a computerized robotic storage device that has 728 bins. The bin number is entered into the machine and it retrieves that drawer for you automatically to the same location, always. You can store many parts in a very small volume.
But though the equipment may be new, the process has remained basically unchanged.
You first have to delineate the resource, find out what you have, where it is, what the stripping ratios may be, what the quality is.
You have to start with some base of knowledge, which usually on a very rough terms, would be the outcrops of the coal, that you can see coal outcropping on a cliff face or whatnot. And from that, you can usually get an attitude of it and get an idea of where the coal is heading, how thick it is, the structure of the coal. And then what we do is lay out a series of drill holes, locations, and we can sink a hole down into the ground in a known location. We'll survey that location in so we get coordinates and an elevation on it. And then as we drill the hole, we see what is coming out of the hole. And when we hit a coal seam at a certain depth, we record that, the thickness of the seam. And then backing out from the coordinates and the elevation, you just subtract that, the depth that you hit the coal seam at, and you would know where the coal is. And then you use the computer, basically, and you can manipulate it through a series of mathematical formulas and whatnot to create a three-dimensional model of the coal seams. Creates a three-dimensional image of that, and you can run plan views of it, so you can run structure maps to see what your coal is doing structure-wise, which way it's diving or dipping, thickness maps of the coal seams to see if it's pinching out or expanding in certain directions. You can run cross-sections, so you can see a cross-sectional view of what's going on, and then it'll also calculate volumes for you and tonnages of coal and stripping ratios, or the yards of overburden that you would have to remove to recover X number of tons.
And a lot of this is concurrent. You're probably doing some of the engineering as you're doing some of the exploration. And design a mine. A mine is like any other technical thing. It is engineered, it is designed. The next phase after it's designed would be the removal of the overburden. And that is a fairly complex operation involving removal part of the overburden which doesn't need to be shot, benching, drilling, shooting, and then moving the overburden, primarily with the drag line. It's a Bucyrus Erie machine. The model is a 1300W, which we purchased, started erecting in 1977 in November, and finished erecting just short of a year later.
The machine weighs 4.25 million pounds. The mast is 186 feet high. That's the mast straight up there, and the boom is 325 feet long. That's a 33-yard bucket. You get a pickup or two in it, I would imagine. We think we're capable of moving 22 million yards in 1 year.
It side casts the material. Cutting a long, narrow pit, about 105 feet of coal is exposed. And at the end of that, it turns around, comes back, refills the hole where we've now removed the coal, and makes the next cut. Secondary stripping is with a shovel and truck. 16-yard O&K machine made in Germany. It puts the material into trucks where it is hauled to its final location. Working with that are our trucks, which are 75-ton WAPCO units. They're powered by 725 horsepower engines, I believe, and are used in two parts of the operation. We use them as they are originally manufactured with rock boxes on them to move our overburden.
Some of that overburden is used to build and rebuild the network of roads throughout the mine site. As the equipment moves to a new mining location, so must the roads. Those same WABCO trucks are modified for use in hauling coal.
The reason for the different box is that coal has about half the density of overburden. So to get the same kind of a load on, you have to have twice the volume.
The trucks come down the road here, and there are usually 3 trucks hauling per shift. And they dump in here in the hopper, and the coal just flows on just a gravity feed down onto a feeder belt, which goes into a stamler, and that's a primary crusher. And it breaks the coal into the about 1 by 1 foot chunks or smaller. and then goes into a secondary crusher, and which is a rolls type crusher, and it breaks it on down into 2-inch minus, and then it feeds onto the conveyor belt and goes across the river to the A-frame and stockpiled in the A-frame in order for it to be loaded out in the coal cars.
Here in the Usibelli headquarters building, a modern laboratory constantly monitors the quality of the coal. Why?
Because many of our contracts are paid for depending on the quality of the coal we ship. And while it varies over a very narrow band, it does vary. So we do an analysis of the coal every day for each customer.
The things that we analyze are for total moisture, ash, volatiles, fixed carbon, sulfur, and BTU. As the train is loaded, the samples are taken automatically, and the tipple man brings me a bag that's filled with the coal sample and labeled. And that's dried overnight in the oven, and then it's pulverized and brought out here to the main part of the lab. The first thing I do is sulfur. Then it goes into the coal analyzer for moisture, volatiles, ash, fixed carbon. And then as that's going on, I'm also doing BTUs on the calorimeter.
It's a big, complicated job running a mine this size, but here in Healy, they get the job done 24 hours a day, 7 days a week, 365 days a year. 1.6 million tons of coal leaves the mine, going north to Fairbanks and south to Seward for the long ride to Korea. But though this coal is on its way to market, the job at the Usibelli mine is far from over.
Part of the stripping involves refilling the holes that you made to remove the coal. Pretty much the largest tractors that are available. Currently using D10 Caterpillar tractors.
And a recent addition, the mighty new D11 from Caterpillar, the largest of its kind. Usibelli was the first customer west of the Mississippi to take delivery of a D11.
My real true love is heavy equipment. I really like big iron.
He does. Those are his big toys. If something goes wrong at the mine or a piece of equipment breaks down, I mean, he's out there because he wants to be a part of that and he wants to see it happen. And I think it's those kind of things that really get him going.
Mining is interesting because really mines lead the world in very large equipment.
To keep that very large equipment running, Usibelli has built and staffed a repair shop as good as any in the state.
Well, we work on just about everything that's on the place. It doesn't matter whether it's the tipple, drag line, or trucks. Primary job is overhauling transmissions for the trucks.
You can do just about anything in there. You can take and build a part from scratch in that shop, with a machine shop. You take a piece of metal and you come out with a finished part. Or as far as major rebuilds go, there's nothing that we can't rebuild in there.
The rebuilding process takes place outside the shop as well, where some of the same big iron is used to restore the disturbed land.
The ground is recontoured and planted, seeded. plant that with fixed-wing aircraft for several reasons. The primary one is that we can get in at an optimum time and can do the job very quickly. We're also on very irregular terrain here, very steep slopes in some cases, and you really couldn't get on it with farm-type equipment. So by using the aircraft to put down both the seed and the fertilizer, we can generally do an entire year's seeding in 3 or 4 days at most. And our concept is that whatever we use is a temporary measure because the natural growth will reinvade, and we have evidence that that is in fact true, and ultimately will establish itself very similar to what it was originally or to what the surrounding terrain supports.
The coal produced from this interior Alaskan mine is best suited for one purpose: to produce electricity.
Well, the coal all over the world is ranked, and we are a subbituminous C. It's a steam quality coal. It is fairly low in heating value because it is quite high in moisture, but it has some other advantages. Extremely low in sulfur, quite low in ash compared to an awful lot of other coal. So as a steam coal for the generation of steam to produce electricity, it is very good for that.
And statistics show the rail belt will need sizable increments of new power generating capacity in the years just ahead. Within 15 to 20 years, the useful life of virtually all of the existing plants will have ended. And with the Susitna Hydro project now written off as too costly, the spotlight is beginning to turn to the one resource Alaska has in abundance.
I would say one of our biggest efforts coming out of this department is really trying to sell the whole idea of coal to people in Alaska.
The next major increment of power generation should be located outside of the Anchorage Bowl. As much as a defense for the Anchorage area as anything else, we now have the intertie. We know that the technology is here now to handily meet the most stringent of air quality regulations. What we're looking at, I think, is addressing that need logically close to where the resource occurs, at the mine mouth, with manageable increments of, let's say, 150 to 200 megawatts.
54% of all the power generated in the United States comes from coal. And that's an increase over what it has been since the 30s. But some of the things that are happening are very exciting. New boiler designs, new techniques, for instance, gasifying coal and burning it as a gas in a combustion turbine rather than going through the intermediate stage of steam. And these are happening to improve two things: the efficiency of the use, so that you get more power for the same amount of energy input, and to improve the emissions levels coming from these plants. And some of the new ones are just amazing.
Usibelli has just unveiled a proposal that would employ that leading-edge technology. A plan to build a large coal-fired power plant at Healy capable of serving the entire rail belt, from Homer to Anchorage to Fairbanks to Delta. A plant that could provide low-cost power far into the future and provide a welcome boost for the state's economy in the process.
Well, we've been looking at this project for quite a while now, a couple of years actually. And the more we look at it, the more exciting it becomes.
Usibelli hired a world-class engineering and construction company, Brown & Root, to analyze rail belt energy requirements and submit a preliminary design for a power plant that would meet the most stringent environmental standards, and an accompanying coal drying facility to remove unwanted moisture from their export product. The technology selected: fluidized bed combustion.
The fluidized bed technology is distinguished from other technologies in that the major pollutants that are produced in the combustion of coal are controlled in the combustion cycle rather than treated at the end of the process. the fluidized bed process will meet the stringent air qualities associated with a Class 1 airshed as we find near the Healy project.
Usibelli's coal exports to a modified plant in Honam, South Korea, capable of burning high-moisture Alaskan coal, have returned over $80 million in new revenues to the state of Alaska. But other Pacific Rim plants have shown little interest in making the costly modifications necessary to burn it. The solution? Dry the coal here before it leaves Alaska.
Beneficiating the coal by using the waste heat from the power plant in order to produce a much more acceptable product, in fact, a product that we think will be in very high demand on the world coal market.
The cost of a 150 megawatt power plant at Healy, given the Alaskan context, would be approximately $230 million. Now that's just the power plant end of things. The coal processing facility could cost between $15 and $25 million. So the total project costs would be of the order of $250 million.
Usibelli and Brown and Root are approaching this project on the basis of market rate financing. Under this scenario, we have been approached by several investment banking firms that have expressed interest in financing the project.
But market rate is a pretty high number and accounts for a substantial amount of the final selling price of the electricity. If the Railbelt Energy Fund were used to collateralize a loan through ADA that would get us a loan at cheaper rates, by reducing that interest rate, the consumers of electricity throughout the entire rail belt will be the beneficiary through lower electrical rates.
Use of monies from the state's Railbelt Energy Fund to collateralize an ADA loan at 8% would lower the project's energy costs from a market rate cost of just under 5 cents per kilowatt hour to 4.3 cents. 6% financing would lower it further to 4.1 cents per kilowatt hour. And a 0% interest rate would enable Usibelli to deliver electricity at 3.3 cents per kilowatt hour. That would result in significant annual savings to the average Railbelt family, and all without depleting the Railbelt Energy Fund.
All we're really using is improving the credit rating of the entire project by using those funds as a guarantee. The fund would not be depleted, and the fund would still be there available in the future for what it was originally intended.
There's a precedent for this type of involvement by our state. This, of course, was the Red Dog zinc lead silver mine project, which is currently under construction in northwest Alaska near Kotzebue. It's a perfect fit, I think, for Governor Cooper's vision of Alaska, where he sees the blending, the melding of high technology, utilizing Alaska's resources, putting Alaskans to work in a quality employment environment, and generating revenues for this state through the export earnings.
Recently, the Alaska State Chamber of Commerce's Commission on Strategic Planning for the 1990s completed a comprehensive study of Alaska's economic development needs. Peter McDowell was its co-chairman.
When you're looking at a project, its principal attraction to achieving the result that many of us desire of expanding and diversifying our economy can be measured by whether or not and how much it contributes to an expansion of exports. We're able to have the quality of life that we desire because of what goes on in the export sectors, which are oil and gas, federal military expenditures, which basically we're exporting our geopolitical location to the U.S. military, fishing, timber. If there's any one phrase or sentence in the entire report that sums up the message we're trying to put across to Alaska's economic leaders, is Alaska needs all the export projects it can get.
And despite the general economic downturn, Alaska will also need additional sources of power generation. Even a modest growth rate, coupled with the retirement of many existing plants, will guarantee a ready market for the Usibelli plant.
If one looks historically at the 20 years prior to 1986, the rail belt experienced a growth in its power requirements on an average annual basis of 9%. We're told by the electrical utilities, and I'm quoting here from figures generated by Chugach Electric, that over the next 20 years, they only foresee a demand growth of about 1% per year. There's an enormous difference between 9% and 1%. I think if one really thinks what 1% is telling us, it's telling us that our economy is going to stagnate indefinitely, that we're going to forsake the economic opportunity, which I think each and every Alaskan is looking for, and we're going to turn our backs on some of the obvious opportunities which face us. And I don't think that's going to be acceptable to Alaskans.
We think that in the range of estimates of power growth in the rail belt area, that the lower ones are probably too low and the high ones are probably too high. The range right now is between 1 and 9%. That's a fantastically wide spread. But we really think that the numbers in the 2.5% to perhaps 3% over 20 years are probably reasonable numbers.
In addition to providing 150 megawatts of much-needed power in the future and fulfilling its role as a world-class export project, the Usibelli plant would mean jobs for Alaskans, both short-term and long-term.
We estimate that during construction at the site at Healy, up to 300 jobs would be involved. These are basically construction jobs, employing skills which are abundant in the Alaskan workforce. We estimate that the total project impact in terms of direct jobs through expansion at the mine, through the power plant requirements, through the coal processing plant, and across the transportation system, the Alaska Railroad and the Port of Seward, would be approximately 175 quality year-round jobs.
And that does not take into account the jobs of the people that would support these people, the grocery stores, the car dealers, the equipment dealers that we deal with, the fuel suppliers and so forth. We feel that this project is the best of all worlds, kind of the ideal project, because it has so many facets that are of direct benefit to the state of Alaska. Number one, the exports, the increased quality of the coal to ensure long-term exports will bring in the export dollars which are essential to build the economy of Alaska. We cannot build the economy without money coming in. We can't do it all by taking out each other's laundry. Secondarily, this will produce inexpensive, stable electrical prices for the entire intertide area for long-term into the future. And it will provide long-term jobs for the next 40 years for 175 or more people. And we think that this is the best of all worlds.
The Usibelli coal mine at Healy in interior Alaska. State-of-the-art, efficient, productive, responsible. Usibelli, with a heritage rooted deeply in the bedrock of Alaska's past and a solid commitment to her future.